Question 15 on the January 2020 Algebra Regents exam, the solutions to the quantity x plus 4 squared minus 2 equals 7 are. For the TI-84 plus family, I would use the solver tool. I would type in, open parentheses, x plus 4, close parentheses, squared minus 2, and in expression 2, I would type in 7. I'd press graph associated with OK, and then I would put in a guess. I'll guess 10. I'll press graph, and I see one solution is -1. I'll guess -10. I'll press graph, and I see -7. Answer 3. On the TI-Nspire, I'll press Menu. I'll choose number 3, Algebra, and I'll choose number 1, Numerical Solve. Open parentheses, x plus 4, close parentheses, squared, minus 2 equals 7. Comma, the variable we're solving for is x, comma, and now we put in our domain that we're looking for a solution. I'm going to put in -10 to -5. When I press enter, I get -7. Up arrow into your history. Press enter to copy and paste. Change your domain. I'll put -5 to 0. And I see the other solution is -1. Again, answer 3. For question 16, which expression is not equivalent to -4 x cubed plus x squared minus 6x plus 8? And we have 4 choices. I recommend 12.3, store into the variable x. Type in the original expression, -4 x raised to the 3rd power plus x squared minus 6x plus 8. Second math, the test feature, choose the equal sign, and now you set it equal to the 4 answers, and we are looking for the one that is not equivalent. Let's try option 2. X times the quantity, -4 x squared minus x plus 6, close parentheses, plus 8. When you press enter, you get a 0. That means this one is not equivalent. For the TI-Nspire, 12.3, store into the variable x. Then type in our expression given in the problem, -4 x raised to the 3rd power plus x squared minus 6x plus 8. We set it equal to the 4 answers below. Let's go right to number 2. X times the quantity -4x squared minus x plus 6, close parentheses, plus 8. We are looking for false, which means it is not equivalent. If you got an error message, please make sure you put in the implied multiplication between the x and the open parentheses. Question 18. The range of the function f of x equals the absolute value of x plus 3 minus 5. On the TI-84 plus, To get absolute value, we will press alpha window, select number 1, put in x plus 3. We'll get outside the absolute value and put in minus 5. We can go to the graph and we see that it goes from -5 inclusive on to infinity. For the TI-Nspire, use the templates key, choose absolute value, type in x plus 3 minus 5, and you will see your graph dips to -5 and goes on to infinity. Option 1. For number 19, the laboratory technician used the function T of m equals 2 times 3 raised to the 2m plus 1. Which of the following expressions is equivalent? We can use our test feature for that. 12.3, store into the variable x, and then type in 2 times 3 raised to the 2x plus 1. Get out of the exponent, set it equal, second math, choose the equal sign. Number 1, 6 times 3 raised to the 2x. That is correct, but we have to check with other options. Up arrow twice, press enter, change it to 6 times 6 to the 2x. That is incorrect. Up arrow twice, press enter, change it to 6 times 9 to the x, and that is correct. So 1 and 3 are correct. Option 3. For the Nspire, let's try it a little different. Let's use a graph to check. 2 times 3 raised to the 2x plus 1. And then we want to know if it's equivalent to, so we can press tab, open up our entry line, in F2, put in 6 times 3 raised to the 2x. When we press enter, it's exactly the same. Tab, let's try option 2, 6 times 6 raised to the 2x. Slightly different, so answer 2 is not equivalent. Option 3, 6 times 9 raised to the x. And again, same as number 1, so 1 and 3 are correct. For question 20, I really want to start with the TI-Nspire technology. Press Menu, choose number 3, Algebra, and notice number 2, Solve Systems of Linear Equations. If we choose number 2, there are 2 equations. Our variables are x and y. I'll say OK. Now I type in the original 3x minus y equals 7, 2x plus 3y equals 12. When I press enter, I see the result of 3, 2. We are looking for a system of equations below that has the same solution as the original 3, 2. Menu, Algebra, Solving Systems of Equations. And we can go through each one of these. Answer 1, 6x minus 2y equals 14, negative 6x plus 9y equals 36. That is not the same solution, so we continue. I'll go to option 2, menu, algebra, solving systems, 18x minus 6y equals 42, 4x plus 6y equals 24. We want a result of 3, 2. This answer is the same as the question, so it is answer 2. For the TI-84 Plus, we'll use matrix. Second, matrix, over to math, and we will use reduced row echelon form, RREF. In RREF, we'll put in a 2x3 matrix, alpha zoom. I see 2 rows, 3 columns. I'll select OK, and now I'll put in my coefficients. 18, negative 6, 42. 4, 6, 24. I see my solution set is 3, 2. Using reduced row echelon form on the TI-84 Plus is how I would recommend solving systems of linear equations. For number 22, the TI-Nspire is the best model to use. I'll scroll up, I'll give a column heading, and now I'll enter in the data given. 65, enter, 70, enter, 70, 70, 70, 80, 80, 80, 85, 90, 90, 95, 95, 95, and 100. There are 15 entries. I'll add a data and statistics page, number 5. Click to add variable, data. It defaults to my dot plot. My dot plot mirrors that of option 1. I'll go to menu. I'll choose number 1, plot type. I'll choose box plot. And the box plot has the same values as option 2. I'll go to menu. I'll choose number 1, plot type. I'll choose histogram. Now it looks a little different, but we can go to menu, choose plot properties, histogram properties, bin settings, and choose number 1, equal bin width. The width is 10, and the starting value is at 61. When I select OK, I can grab and move and see that my data has 5 in the first column, 3, 3, 4, 5, 3, 3, 4. So we will agree with answers 1, 2, and 3, option 4 for number 20. As the TI-84 Plus does not have a dot plot, I would not recommend using the TI-84 for this example.